Action, reaction, motion, a measurable quantity that depends on your frame of reference that describes the object in terms of position, velocity, acceleration, and time. Jean-Pierre Gaultier's inventive exhibit, Machines at Play, gives us a unique platform to visualize and imagine aspects of energy. We look to 17th century physicist Sir Isaac Newton for the laws that govern the forces that make objects move. His first law tells us that if an object like a book is lying on a table, it remains in that state unless somebody moves it with force. His second law says the rate of change of momentum of a body is directly proportional to the implied force and takes place in the direction of the force. Thirdly, Newton says to every action there is always an equal in magnitude and opposite in direction reaction. Acceleration is proportional to the net force acting on the object and inversely proportional to the mass of the object. Which of Newton's three laws of motion do you think govern acceleration? With each stroke, the swimmer exerts a force on the water that exerts an equal force back onto the swimmer. The swimmer is a living example of Newton's third law of motion. For every action, there is an equal and opposite reaction. Friction constrains the motion of an object. Here, the severity of the curve and the speed of the car change the shape of the tires. Newton's second law of motion governs the rate of change of the car's momentum. The curve adds the friction to become a force for the car and driver to reckon with. Time, movement, transformation. Through the use of motion detectors, relays, microcontrollers, and transformers, Gaultier's beats and butterflies can illustrate how Newton's three laws of motion can combine to turn mechanical and electrical energy into music.